Hello and welcome to Mr. Walton's physics lessons. In today's lesson we'll be looking at specific latent heat from the particle model of matter topic of GCSE Combined Science and GCSE Physics. By the end of the lesson you should know what is meant by the term specific latent heat, and be able to use it in calculations. Latent heat is the energy transferred into, or out of, a substance, when it changes state, without changing its temperature. For example, a solid, like this ice cream, melting on a hot day. Or a liquid, like water in a kettle, boiling. Both of these processes need energy to make them happen. As a solid melts into a liquid, or a liquid boils to become a gas, the energy goes into weakening and breaking the bonds between the particles, rather than heating the substance, so changes of state happen at a constant temperature. As a gas turns into a liquid, energy is given out by the substance. The particles slow down and bonds are remade between the particles. This is called condensing. As the liquid cools further, particles will eventually create strong bonds and turn back into a solid. This process is called freezing. As with the other changes of state, the temperature remains constant during the change. The specific latent heat of a substance is the energy needed to change the state of 1 kilogram of the substance. This is shown in the formula: specific latent heat equals energy transferred divided by mass, or L equals E divided by M. The unit of specific heat capacity is joules per kilogram. The amount of energy needed to melt or freeze 1 kilogram of a substance at its melting point is known as the specific latent heat of fusion. The formula can be rearranged to give energy transferred equals mass times specific latent heat of fusion, or E equals M times L. As melting is a different process to boiling, the energy requirements are different, so each substance has two specific latent heat values. The amount of energy needed to boil or condense 1 kilogram of a substance at its boiling point is known as the specific latent heat of vaporization. The formula needed to calculate the energy transferred is the same, but the specific latent heat value will be different. Let's try some example questions. Number 1, the specific latent heat of fusion of water is 334,000 joules per kilogram. Calculate the energy required to melt 50 grams of ice. Number 2, the specific latent heat of vaporization of ethanol is 855,000 joules per kilogram. Calculate the energy required to boil 0.4 kilograms of ethanol. Pause the lesson and restart when you're ready to check your answers. To calculate the energy required to melt the ice, we need to use the formula, energy equals mass times specific latent heat of fusion. The mass is given in grams, so firstly we need to divide 50 by 1000 to get 0.05 kilograms. Which gives the energy required to melt 50 grams of ice to be 16,700 joules or 16.7 kilojoules. To calculate the energy required to boil the ethanol, we need to use the formula energy equals mass times specific latent heat of vaporization. Which gives the energy required to boil 0.4 kilograms of ethanol to be 354,000 joules or 354 kilojoules. So to summarize, latent heat is the energy needed to change the state of a substance, and this happens without changing its temperature. Specific latent heat of fusion is the energy needed to melt or freeze 1 kilogram of a substance, without changing its temperature. The specific latent heat of vaporization is the energy needed to boil or condense 1 kilogram of a substance, at a constant temperature. To make calculations of specific latent heat, we use the formula E equals M times L. If you found this lesson useful, please give it a like and subscribe so that you don't miss any future lessons. Thank you for watching. I'll see you next time.